Okay, in previous lecture we have seen a raised to n, b raised to n, where we have equal number of a's and equal number of b's. Number of a's equal to number of b's. Our next example is a raised to m, b raised to n, a raised to m, b raised to n, where m is greater than n. What is the meaning of this? The meaning is number of a's are greater than number of b's. What logic did we apply for a raised to n, b raised to n? For every a, push one x onto the stack. For every b, pop x from the stack. So at the end, when I read a blank, the stack should be empty. This was the logic for a raised to n, b raised to n. So now the logic will be the same. If I have 3 a's and 2b. Okay, I hope you remember. If the stack is empty, we represent it by R or we represent it by Z. I'll take Z here. Okay, now when we read first A, now here number of A's are greater than number of B in this example. And what is our logic? For every A, push 1x. For every B, pop x. Okay, so for the first A, I'll push x. For first A, I have already pushed 1x. For second A, push x. For third A, push x. Okay, when we read B, what we have to do? We have to pop. For first B, I have popped. For the second B, we'll pop one more x. Then, what is the condition to accept? When I read a blank, I should have some element in the stack. One or more element in the stack. So when I read a blank, I should have one or more x in the stack. I hope this is clear. Okay, so how to write this then? See, a raised to m, b raised to n, where m is greater than n. I have taken this from our previous example, a raised to n, b raised to n. For first A, empty stack, push 1x. For next A, when stack has some element, push one more x when you read a A. When you start reading B, what do you have to do? You have to pop. I hope this is clear till here. It is same as a raised to n, b raised to n till this step. What will be our final answer? When you read a blank, top of the stack should be x. Maybe 1x, 2x, 3x, we are not bothered about that. But stack should have more than 1x, one or more than 1x. And go to the final state and keep this as it is. Hope this is clear for a raised to m, b raised to n, where m is greater than n. Now we will see one more example where n is greater than m. So, n is greater than m. For this, a raised to m, b raised to n, where n is greater than m. What do you mean by this? Number of b's should be greater than number of a's. So what happens if I have 2a and 3 b's? z at the bottom. Okay. So for this, the logic is same as a raised to n, b raised to n again. For every a, push 1x. For every b, pop. Okay, at the end we'll see whether we have more b's. For the first a, top of the stack is empty, push x. For second a, top of the stack is x, push one more x. Now when you read first b, top of the stack is x, pop. Second b, pop. I don't know how many b's you have here, but when you read a b, top of the stack is empty. So this represents that number of a's are lesser than number of b's. Hope the example is clear. So how to represent this? One more thing you have to remember here is, I shouldn't encounter any a's here. So I have to go till blank to reach the final state. I have to read all the b's to check that there are no a's after this b. Okay, I hope this is clear. So how to write this? Okay, I have taken the same as a raised to n, b raised to n. We'll make changes in that. So 1, 2, 3, 4. Till here it is same. For every a, push x. For every b, pop. Okay. Now when you read a b, top was empty, right? Okay. So go to next state, Q2, and let z be as it is. Okay, after this, what do you have to do? We have verified that number of b's are more than number of a's. Here only. But now, as I said in this, we have to check that after b, there are no a's. So we have to go till blank. So for this, what we'll be writing? We'll be writing one more step. Q2, B, Z, Q2, Z. Okay, and then when you read a blank, and top of the stack is empty, go to final state. Hope this is clear. Okay. That is, what we have done till here is same as a raised to n, b raised to n. What we have done here, we have seen that b, number of b is greater than number of a. But we have to check that after reading this b, we have only b in the string, not a or any other character. So we have done this operation. Okay. And then once we reached blank, that is last element has been reached, we will go to final state and accept the string. I hope this is clear. Okay. So we have solved two examples in this. One is a raised to m, b raised to n, where m is greater than n, and another is a raised to m, b raised to n, where m is less than n. I hope this is clear. Thank you.